In this study, we will investigate a building that fits the use of geometric elements in its design, namely the Gherkin. This building, also known as 30 St. Mary Axe, is one of the capital's most famous landmarks in London, United Kingdom. The Gherkin was designed by famed architect Norman Foster from the Foster and Partners architectural firm with the help of Arup Group as a structural engineer. In 1992, an explosion rocked the financial district of London as the Provisional Irish Republican Army detonated an explosive device near the Baltic Exchange. The old building was torn down and the site was then sold to Trafalgar House in 1995. In 1996, Trafalgar House submitted plan for Millennium Tower, but the plan was dropped because it was totally out of the scale in the City of London. In late 1997, a reinsuring company, Swiss Re, bought the site and commissioned Foster and Partners to design the Gherkin. The Deputy Prime Minister, John Prescott, granted planning permission in 2000. The construction began in 2001 and it was finished in December 2003. The Gherkin was opened to the public in April 2004. The Gherkin is a commercial skyscraper in the London Primary Financial District in the City of London. It is close to Leadenhall Market and the Bank of England Museum. The total site area of the Gherkin is about 0.57 hectares. The total surface area of the Gherkin is about 24,000 meters square. The height of the Gherkin to the top of dome is 179.8 meters. The Gherkin has 40 floors above the ground. The height between the floor to floor is 4.2 meters. Every floor is rotated by 5 degrees. The floor diameter for the base of the Gherkin is 49 meters and the top has a diameter of 26.5 meters. The largest floor diameter is 56.5 meters, which is on level 16. Originally, after the construction of the building was completed in 2004, the Gherkin served as a headquarters of Swiss Re. Today, the Gherkin is a primarily office building. In addition, the Gherkin provides meeting room for corporate events. There are also available spaces for special occasions such as wedding and birthday parties. Plus, there are restaurant amenities at the Gherkin such as Hilly Restaurant that offers sky-high contemporary all-day dining.
Hi, I'm going to proceed with the geometrical shape of the Gherkin. The Gherkin is a combination of various shapes such as cylinder, where it applied the concept of aerodynamic. The second shape is semi-ellipsoid. It is the shape of the dome of the building, where it allowed the visitors to have a 360 degrees views of London. The third shape is circle, where every floor in the building have a circular shape. The fourth shape is a rhombus, where the exterior design of the building is covered with a rhombus glass and also rhombus frame. The fifth shape is triangle, where the windows of the building is in a triangular shape. The next part is the geometrical concept of the Gherkin. For the cylinder shape, the overall cylindrical shape allows the wind to move around the building. As I mentioned before, it applied the concept of aerodynamic. And by definition, a right circular cylinder is where the axis line is perpendicular with the circular base. However, the Gherkin have a curve on it. Therefore, we make an assumption that the Gherkin is a building with a right circular cylinder by neglecting the curve on it to do the calculation using the cylindrical formula. From our research, we found that the height of the cylinder, exclude the dome, is 167.1 meter, and the diameter of the basement is 49 in meter. We divide it by 2, and the radius will be 24.5 meter. And by using the cylindrical formula to find the area and the volume, we substitute it and we get 29,494.5 meters squared. And the volume of the cylinder is substituted, we get 315,107.3 meters cubed. However, there is a difference in the calculation since we neglect the curve. Therefore, in order to get an accurate measurement, we need to apply our calculus knowledge by using the equation of parabola to find the surface area and volume of solid revolution to find the volume of the gherkin. The next shape is semi-ellipsoid. An ellipsoid is actually seen as a stretched sphere, and it has 3 axis rotational symmetry. Those 3 axes are perpendicular to each other, and the gherkin dome is in the form of oblate spheroid. That means 2 of the axes are equal in measure and the third axes are smaller. The height of the dome or the semi-ellipsoid is the difference between the total height of the building and the cylindrical part. It is 12.7 meter. As I mentioned before, axes A and B are equal in measure, and it is actually equivalent to the radius of the 40th floor, which is 13.25 meter. And after we substitute all the information, we multiply it with 1/2 since the dome is semi-ellipsoid and the area of the dome is 1072.7 meters square. Same goes to the volume. As we substitute it, we divide it into 2 and the volume is 4,669.76 meter cube.
Now let's proceed with the next geometrical concept, which is circular. The interior shape of the gherkin shows it is in circular shape with different diameter on every level. Diameter is a chord that contains the center of the circle. We've picked some floors to do the calculation, which is the lowest, the highest, and the widest. The diameter for the ground floor, the widest floor, which is the 60th level, and the top floor is 49 meter, 56.5 meter, and 26.5 meter respectively. The radius for all 3 floors given is half of the diameter of the floor, which is 24.5 meter, 28.25 meter, and 13.25 meter. You can determine the circumferences by multiply the value of pi and the diameter. The area of every level are different from each other and denoted by A and can be determined by multiply the value of pi and the square of radius, which is denoted by r square. The details value of the circumferences and the areas are given on this table. Let's continue with rhombus. The outer surface of this building is closed with 5,500 flat glass of rhombus shape. A frame is attached as the main structure of the building and also have the rhombus shape. Both of the rhombus are parallelogram and quadrilateral in which all sides have same length. The height of the rhombus glass is 4.2 meters, which also the vertical diagonal of the glass. And the height of the rhombus frame is 16.8 meters, which also the vertical diagonal of the frame. We also can get the angle of the horizontal sides is 120 degrees. By using the angles and the vertical diagonal measurements, we also can find the horizontal diagonal by using this basic mathematical calculation. We also can calculate the area of the rhombus by multiplying half with vertical diagonal and horizontal diagonal. By the formula, we can get that the area of the rhombus glass and the rhombus frame are 5.04 meters square and 80.64 meters square. As of the triangle, it can be seen on the circular plane of every floor, and a triangular pane act as the window to control the temperature inside the building. For the triangular window, we know that it is an equiangular triangle because it has the same angle value of the rhombus. The area of the triangle can be calculated by multiply half with base of the triangle and height of the triangle. The window is an isosceles triangle, and actually the half of the rhombus. Then the height of the triangle is 2.1 meters and the base of the triangle is 2.4 meters. Then we can calculate the area and get 2.52 meters square. By using the rhombus figure, we can get the length of the triangle leg, which is 2.4 meter. Since it is an isosceles triangle, then the legs are equal in measure. As we see it carefully, the length of all sides are congruent with 2.4 meters. We can say that the window is an equilateral triangle with perimeter of 7.2 meters.
The cross-section of the building is seen in 2D shape and divided into two types, which is vertical and horizontal cross-section. Vertical cross-section from the building depicts two parts of shape, with part A represents semi-ellipse and part B represents rectangle. For part A, ellipse is family of circle but with different radius that called major axis and minor axis. From the cross-section, major axis is equal to the diameter of highest floor of the building and minor axis is the height from the highest floor to the top of the building. Perimeter for the shape can be measured by multiplication of half to pi and square root of a square plus b square over 2. Therefore, the perimeter is 40.77 meters. The area for this cross-section can be measured by multiplication of pi AB and divided into half. The total area is 264.33 meters square. Part B is rectangle. A rectangle is parallelogram that has right angle. We're neglecting the curve from the building, so we assume that the cross-section has a rectangle shape. The height of the rectangle is 167.1 meters and the base length equal to diameter of the ground floor. The perimeter of this rectangle cross-section can be measured by summation of the length of all sides that yield 333.2 meters. The area bounded can be measured by multiplication of the base and height that obtain 4093.95 meters square. The sum of interior angle for rectangle is 360 degree, hence it is coherent with the definition of rectangle. Next, horizontal cross-section of the building form a circle shape. By definition, a circle is a set of all points that are most distance from the center. Since this building getting higher, the diameter is getting smaller. By taking the diameter of the widest floor and the highest floor, we can calculate the circumference of both circles by multiplication of pi and diameter that yield 177.5 meters for inner circle and 83.25 meters for outer circle. Hence, the different radius between these two circles is 15 meters. Besides that, from the cross-section of 21st floor appearing a triangular hollow wedges, the triangle base equal to the length of horizontal diagonal for the rhombus frame and its height is half from the rhombus height. This hollow triangle has the same measure as half of the frame in shape of rhombus that has been calculated before. Hence, the perimeter is 25.2 meters. If we combine the 6 triangle wedges, it yields a 360 degree center angles, means that the vertex angle is 60 degree each. The sum of interior angle of this triangle is 180 degree and both legs angle will be 60 degree. The area bounded for this triangle is multiplication of half base and height that yields 40.32 meters square.
In summary, the Gherkin is an iconic building with a unique structure. This building is very beautiful, elegant, and modern that can attract so many people to come. From what we have investigated in Part B, we assume that the Gherkin has the cylindrical shape for the main part of the building and semi-ellipse shape for the dome. For the interior design of this building, there are circle shape for the base and triangular shape for the windows and the wedges of this building. Next, for the exterior design, the architect has designed a rhombus cut shape for the glasses mirror and triangular prism for the entrance of the building. So we can assume that the Gherkin is one of the building with so many geometrical shapes. But if we investigated it in detail, we can know that there are certain part of this building is not in the syllabus of our course. So in future, we hope that we can learn more in this course so that we can know what is the part that we can design in that building. In conclusion, there are so many lessons that we have studied in this task, such as we can work in a group and cooperate together as a team. Next, we also learn how to apply the knowledge that we have studied in these courses in our daily life. It helps us to understand the theorem and the concept of geometry. For the culture of this building is more likely to modern culture because the main reason of the architect who built this building is to show the modernity of the economy of this country. So we can say that this building has a unique features that can explain the culture of its country, which is modern and following the current development. This building will always be an iconic building in every civilization. That's all from me. Thank you.